All right, let's jump straight into today's recap, or the recap of what we did on Monday. I'm going to give you guys a set of numbers, and I'm going to give it to you in set builder notation. And if you've got your book next to you, I want you to write it down, and then I want you to draw a number line and represent it on the number line. And then you can pop your favorite emoji in the chat once you're ready. All right. Okay. I am going to start by saying I've got some number x such that x is in between -2 and 4. Let's make it 4. And I want x to be a part of the real number family. Okay, and that last part is very important because it helps us know exactly how it is we need to express our number line or our numbers on the number line. So I'm going to give you guys 2 minutes where draw this quickly. Your number line doesn't have to be a work of art. It can just be a line with the 2 numbers that we need. I'll show you how much easier it becomes as we get a little bit older. We're going to be doing a quick example of these. All right, Tero and Cornelia, I hope you guys are doing okay. Please do let me know in the chat if you're still confused. If you're joining us for the first time, please let me know just so I can get an idea of where you guys are. Excellent, my sweetie. Beautiful. Thank you, Tero. No worries. Hi, Tandalwetu. Welcome. It's lovely to have you. It's good to see you again. We are all just drawing the number or the set that ma'am has put on the screen on our number line. So you can draw a quick number line and just tell us what you think it should look like. Okay. Hello, Tsepo.
Hi, ma'am.
How are you doing,
How are you doing, my sweetie? I'm good, and you?
Good, thank you. There's a bit of an echo.
Ish.
Oh, it's
Ish.
gone. It's gone. Ooh,
Okay.
lovely. All right.
I'd
What's
like
up, my
to
sweetie? Oh, yes,
Yes.
absolutely. Love it. Yes.
So
Okay, are you ready?
I didn't join, but we did this in class, so I think I do know it. So yeah.
Absolutely. Remember, what I'm doing is just helping you if you're a bit stuck with what your teacher's done. All right. Okay, so where are we going to start? What are you going to do?
So by -2, you're gonna put a circle, and then you're gonna shade it.
Beautiful. Yes, we're off to a great start.
And then by 4, you're gonna put a circle, but you won't shade it.
Ah, excellent.
And then you're gonna connect these 2's with a line in between.
You are a legend, and I need to draw straighter lines, but
Yes.
you have made 0 mistakes and you've told 0 lies. I'm just really bad at drawing.
Yes, ma'am. Thank you.
Very, very well done. I do need to ask, though, before we go, why
Yes.
did you shade that dot in, but not that one?
I shaded that circle by -2 because I think when you write it in a statement, you're gonna say including -2.
Okay, including. So this would be this part over here. Which part of this?
Yes, I forgot that. Yes. By the signs, there's another line underneath by that less than
That
sign.
one right there.
Yes.
Yes.
Which
That one means
tells us that we should like shade it.
beautiful. Oh, 100% was so right. and just
Thank
on
you.
point. Well done. Well
Thank
done.
you.
Amazing stuff. Sure. Tshego for the win, everybody. Love it, love it, love it. If any of you also want to unmute and give me an answer, I'm happy to hear your voices. I think there are few enough in the class that if any of you want to answer, I'm just going to give you guys freedom to unmute yourselves and answer my questions for me. If you would like, I'm happy for us to have a small, intimate conversation for today. All right. Now, remember, guys, this is set builder notation. This is what we call set builder. Set builder notation. And then we learned about a different kind of notation called interval notation. And interval notation uses certain kinds of brackets. Does anybody remember what kind of brackets we use for interval notation? I can tell, I'll give you a hint. It's not the curly brackets. It's not the curly brackets anymore. Who remembers? Block brackets, yes, Tandulutu, that's one of them. What else? So we can call them square brackets. And what other kind of brackets? Who remembers? Okay, so we had square brackets and we had round brackets. Okay, and that's where we left off in the last lesson. Yes, correct, the round brackets, that's it, Desmarie, good. Okay, so we said that if we want to express this, we can say that x must be an element of. Now, if I draw round brackets and then I go -3, 1, okay, what do the round brackets tell me? What do the round brackets tell me? What do we remember? Anybody remember what it means? Okay, it means excluded. Excluded. Just like Tshego was saying about coloring, shading in the dot and not shading in the dot, the round brackets are going to mean excluded. So does anybody remember where are we going to start? Where do we start when we're drawing our interval notation? Where would we start? We would put a dot at what number? Okay, at -3. Okay, because it's excluded. And then we would go to 1 and we would put another open dot and we wouldn't shade it in because it's excluded, right? Yes, I see you. Good. Because of the round brackets. Yes, Desmarie, that's it. And then we're just going to join these two with a line. But also we can even say that x is an element of real numbers here if we're going to join it with a line. Let me ask, if I said to you guys that I've got x is part of the set and then I draw square brackets and I start at 0 and I go to infinity and then I put square brackets. Where would I start and what would I draw where? Okay, think about what this means, what this bracket over here means. If that one means excluded, this one will then mean included, right? Which means we'd have to shade in our dot. All right, we'd have to shade our dot in. So we're going to go to 0 and we're going to shade in our dot. Like that. Okay. Then we know that we're going to infinity. So we don't exactly know where infinity ends. Nobody does. Really, there's no number for infinity. There's no last number. So we're just going to draw an arrow going in that direction. Okay. Give me a thumbs up. Are we all okay with this? Is everybody with me here? Beautiful. Excellent, Tshego. That's it, Desmarie. Thank you. All right. Thank you, Tanduluti. Excellent. All right, so this is what we did when we were talking about representing numbers on a number line. So I'm going to give you guys a bit of an exercise to do yourselves, but this time I'm not going to give you the interval notation or the set builder notation. I'm going to give you guys the drawing, and you guys need to give me the set builder notation and the interval notation, and then we're going to see whether what you have matches what I have. Okay, so here is your exercise. Okay, it says here, give the set builder notation. Right, now remember, guys, I will remind you a little bit. Set builder notation is the one with the curly brackets on each side. Okay, so what we're going to have to do now is we're going to have to take this interval notation and we're going to have to rewrite it in set builder notation. Okay, same with this one over here. We're going to have to take this interval notation and rewrite it in set builder notation. Give me a thumbs up if you're like, ma'am, I think I got it. Do we think we can do it? Excellent. All right. I'm going to give you guys about 5 minutes. When you're done, maybe let's just do A, B, C, and D. It shouldn't take us too long. I want you guys to give me your favorite emoji in the chat. I'm going to put mine today because my mood is kind of weird today. So I'm going to put my favorite emoji, let me see, how am I feeling today? That's how I'm feeling today. There. Okay, Tandilwetu, remember, curly brackets just means set builder notation. Look at the difference. Okay, when we're doing set builder notation, which looks like that, we use curly brackets. But when we look at interval notation, we've got round brackets or we've got square brackets. Okay, so when we say set builder, we mean like the curly brackets, like build something in between the brackets. Okay, you think you can do it? I think you can. Give it a try, dude. Yeah. Few more minutes, guys. All right, guys, that's time. Okay, let's have a look if your answers are going to look like mine. Okay, let's start with A. We're going to start with A. Now, I know that my set builder notation always starts with curly brackets. So that's where I'm going to start. I'm going to open curly brackets. And I'm going to go, I have some number x such that x needs to be in between these two numbers. X needs to be in between 6 and 3. But I know that this bracket means included, and that bracket means excluded. And I know that if there's an included, I need to put in there an or equals to. So underneath this inequality, I must put an or equal to sign there. And I know because it's in interval notation and they haven't given us any other instructions, we must add that x is an element of real numbers and close curly brackets. Give me a thumbs up. Does yours look like mine? Thumbs down if it doesn't. That's perfectly fine. Yes, Tero.
Ma'am, I wanted to know by the greater and lesser than sign, if like the x is in between, the sign should be less than, or if x is
Yes.
in, like if x is between two numbers.
Okay, let's put it this way. If we had to draw this this interval notation that they've given us here, right? If I had to put it on a number line, I would have a mark at 3, and because there's square brackets, I would shade in my dot. Do you agree with me? This is at 3.
Yes.
Yes? And then at 6, I would do that. Now, if we think about this, if this is the way we're going to join them, x needs to be in between these two. Can you think of any number in between 3 and 6? Give me a number.
2, no, wait, 4, 5.
Good, 4 or 5, right? Let's just go with 4. Now, if x is gonna be 4, between this 3 and that 4, which number is bigger?
4.
4. So my my inequality must open towards 4.
Oh, okay, I get
Now,
it.
if we look at this one, if we now between 4 and 6, which one is bigger? 6 is bigger, so my inequality must open towards 6.
Oh, okay. Thank you.
Makes sense.
Yes.
Beautiful. Good question. Very nice question. Well done. All right. I hope everybody's okay with why the inequality signs look the way that they do. If you're still not clear, I'm happy to give another example. All right. Okay. Let's look at the next one over here. This number B. I meant B. But you guys know what I meant. Yes. Okay. In this one, they explicitly tell us that x must be an element of z. And we know that z, we learned about z on Monday. We said that z means the set of integers. That's what z means, set of integers. So when we write this out in interval notation, or not interval, set builder notation, because this is what we're trying to write out, we're always going to start with our curly brackets. So squiggly brackets. I want some number x such that x must be in between -4 and 5. And now I know what my brackets mean. That round bracket there means excluded. And the square brackets over there mean included. So at -4, I'm going to draw a number, a line like that. And on this side, I'm going to draw less than or equal to, because it's included. And then we're going to say that x is an element of integers. But what they're actually doing is they're cheating us, right? Tell me, guys, when we talk about integers, does 3,5 count when we talk about integers? Yes, no, what do we think? No, it doesn't count. No, not at all. It doesn't, because our integers need to be whole numbers. They need to be positive or negative whole numbers. So if we look at all the numbers that are integers, between 4 and 5. Oh, -4, not negative. Oh, yes, never mind. I thought it was 4. I'm sorry, guys. Please disregard that. I thought it was 4. Because my answer, technically, if it was between 4 and 5, then the only answer I would be able to accept is 5. Because if 4 isn't included, I can't include 4,5. I can't include 4,6. So no, never mind. Okay, rewind. Everybody, rewind. No, ma'am didn't say anything. Okay, I didn't say anything. Okay, the question is correct. Okay, I'm not. Relax, don't stress. Okay, but we can number them. We can actually put out the set of the numbers. We know that the numbers, -4 is not included. So this would start at -3, -2, -1, 0, 1, 2, 3, 4, and 5. That is the whole set that we would get from that. Okay. That's what we would get in that instance. All right. Okay, let's look at C. Let's look at C. Okay, remember when we were drawing integers, guys, we said that we can't include everything in the middle. So this part wouldn't count. The part in between 4 and 5 wouldn't count. So before we even write out our set builder notation, we already know, is this going to be this representation? Is it going to be an integer or a real number? What is X going to be an element of? Integers or real numbers? What do we think? Who remembers? Okay, it's going to be real numbers, right? Because if it was integers, yes, correct, Handler2. Because if it were integers, we would have a dot here, and a dot there, and a dot there, and a dot there, because nothing in between is included. But when they draw an arrow like that, we automatically know that it's real numbers because we're including all the numbers in between. All right, let's start our set builder notation. So I'm going to start curly brackets. I'm looking for some number X such that X, okay, there's no need, X isn't in between anything. X is just going on and on forever, but X now needs to be any number bigger than 4. So I'm going to go, X needs to be greater than 4, and X needs to be an element of real numbers. Ma'am has forgotten something. Tell me what I've forgotten. Who knows? What did I forget? Yes, Cero.
By the sign, the greater sign, you need to put that small line underneath the.
Yes,
Yeah, that
correct. 4, 2. Why?
Because the circle is shaded.
Beautiful. 100%. Yes, because our dot is shaded in, right? Guys, winning. I see you guys today. You got this. You got this. Well done. Good. So we need to put the all equal to because our dot is shaded. All right, let's talk about D. Okay, I'm going to open brackets and I'm going to say, I have some number X such that now I know that X needs to be in between two numbers. So I'm going to put X in the middle, and then I'm going to put -4 on this side, and I'm going to put 3 on this side. And again, because it's a solid line, that tells me that X is going to be an element of real numbers. Now, remember again, guys, if my X is sitting in between here, let's say, for instance, X is at -1. We know that between -4 and -1, -1 is the bigger number. So my sign must open towards X. Okay, but because it's also equal to, because our dot is shaded, this should be -4 is less than or equal to X. And on this side, 3 is definitely bigger than X. So this must be X must be less than 3. Okay, give me a thumbs up. Do your answers look like mine? Yes? I see Desmarais is clapping. I'm glad. Yes, 100%. Well done, Thandoleti. Well done, Seho. Beautiful, guys. All right. Can we move on to some algebra? Yeah? I feel like we've got this in the bag. This is nice and easy. We're now like, oh man, we've got this. It's like in the brain now. It's never going to leave. I'm going to get my first 5 marks for free because this is always the first few marks of that first test you're going to write. This is the first few marks in grade 10. All right, let's move on to some grade 9 revision of algebraic expressions. Okay. Now, this is simple things, but I'm just going to remind you guys of some of the rules that we need to remember in mathematics as we go along. So when we look at sums like this, what we actually want to do is, ooh, let me remove this. I don't think we actually need that. All right, first thing we always do, number 1 rule, whenever we have any paper, I fight about this with my kids all the time. I'll be like, what is the number 1 rule, guys? And they'll be like, write your name, ma'am. I'm like, no, don't write your name. And they'll be like, write the date. No, it's not the date. Write down the question. No, ma'am, it's not. It's not. The first thing we always have to do is read the question. Okay. Guys, I've been doing this a long time, and you would be surprised the number of times kids have lost marks just because they didn't read the question. So make sure when you get your paper, make sure that you're understanding everything that's happening and read the question. Okay, start by reading the question so that things just don't make sense. Now, in any question like this, when we're simplifying, the question will say simplify, or the instruction will say simplify. Imagine if we didn't read that part and the question said, state the variable. State the variable. And all you had to do was say that the variable was x, the variable is x, and you're losing marks just because you didn't read the question. No, we need to read the question first. That is the first step. But I'm kidding, that's not today's question. That's not today's instruction. Today's instruction is simplify. Okay. Simplify. And what I like to call simplify, basically, simplification basically means take away the brackets. Take them away. Take away the brackets. And how do we take away the brackets in mathematics? When we see brackets, we know we need to multiply. We're going to multiply. That's how we take the brackets away. Okay. Simplify means take away the brackets. How do we take away the brackets? By multiplying everything there is. Give me a thumbs up if you think you can answer questions 1, 2, 3, and 4 without me. Do you think we can do it? Excellent. All right, I'm going to give you another 5 minutes again. Do what you need to do. I'm going to go quickly grab myself a glass of water, and when I come back, we're going to be ready to go. Okay. We'll just pretend that there's elevator music playing in the background. Okay. I'll be right back. Okay. I'm sorry, Tandalwet, you literally only have 2 minutes left to do it. I don't know what to tell you. Because I only just saw your message. So we were going from 1 till 4. Okay, but now you've got 1 minute left. It's okay if you don't finish. Nice thing about extra maths is that there's no marks. We're just doing this so that you guys can get better, which is kind of nice. All right, peeps, that's time. It's okay if you're not done. We're just going to go ahead and see what these questions are about. Okay, so first one is nice and easy. I know that x times x is just going to give me x squared. Okay, that's what I should get for the first one. So that one was nice and easy. Give yourself a tick if you got it. All right, next thing we're going to do over here, when we see the brackets with something on the inside, we're going to distribute. Okay, in my class, we call it a top. Okay, top. So 5x times x is going to give us 5x squared. And then 5x times negative 6 is going to give us negative 30x. That's what we've got there. All right. If we look at number 3, I know that I've got 2 binomials being multiplied with each other. Yes, absolutely. It's still fine. Good. So in number 3, we're going to have to use FOIL. Okay. So first, outer, inner, last. All right, let's do the firsts. First with first is going to give me 12. I forgot my equal sign. 12x squared. And then outer, 3x with outer is negative 6. 3x times negative 6y is going to give me negative 18xy. And then I'm going to do inner. That's 2y multiplied by 4x. That's going to give us positive 8xy or positive 8yx. We can write it as xy or yx. They're both the same thing. They're like terms. So I'm just going to write it as xy. And then we're going to do the lasts. We're going to do 2y multiplied by negative 6y, which is going to give me negative 12y squared. And then we're not quite done. We still need to add like terms. So that's what we're going to do. I know that negative 18xy and positive 8xy, those two are like terms. So I'm going to leave everything else exactly the way I see it. 12x squared. Negative 18xy plus 8xy will give me negative 10xy minus 12y squared. Wonderful stuff. All right. Again, over here, we've got FOIL. So we're going to do first with first, and then outer with outer, and then we're going to do inner with inner, and last with last. All right. So x times x is going to give us x squared. X times negative 7 will give us negative 7x. 7 times x will give us positive 7x. And then 7 times negative 7 will give us negative 49. All right. And the nice thing about this one, it is a perfect square. Okay. It's just the simplification of the difference of 2 squares. Negative 7x plus 7x will give us 0. And my final answer would be x squared minus 49. All right. Give me your mark out of 4. That's 1, 2, 3, 4. How much did we get? What did we do? How did we do? Are we all good? I hope everybody's fine here. I don't think any of the stuff is hard. Not yet. And we're going to try and keep it here. Keep it simple, nice and easy. Oh, now well done, Tandalwet, 4 out of 4. Excellent. All right, we're going to continue quickly. I just want us to do number 5 because that's something we do see quite often. It's the squared over here, the one that's on the outside of my bracket. Now, we need to remember, guys, oh, beautiful, Desmarais, well done, well done. All right, so we're going to, we tend to want to do this. We tend to want to take that 2, multiply x squared by it, or x by it, and then take that 2 and multiply -4 by it. And that's incorrect. We don't do that. Because we know that x squared is the same as x times x. If we see that x squared is the same thing 2 times, that means that if x minus 4 is all squared, we need to rewrite x minus 4 2 times. And then we're going to have to do FOIL again. Right, so we're going to get -2, and then I must rewrite this twice. I must go x minus 4, x minus 4. Now we're going to let this -2 chill there for a second. We'll come back to him in just a bit. Let's do the rest of it. Okay, I'm going to leave -2 there, and I still need to multiply my -2 in. So I'm going to do FOIL again. X times x, first and first, outer with outer, inner with inner, and last with last. Okay, so we're going to get x squared, and then x times -4 will give us -4x, -4 times x would give us -4x, and then -4 times -4 will give us positive 16, right? Which is lovely, but we're not quite done. We're not done because that -2 is still sitting on the outside and we haven't simplified. So now we have to take that -2 and multiply it in. We're going to multiply it in. I'm going to carry on up here, all right? So -2 times x squared is going to give me -2x squared. -2 times -4 will give us positive 8x. Again, -2 times -4x will give us positive 8x. And -2 times positive 16 will give us -32. All right, now I'm going to add like terms. -2x squared. My 2 like terms are 8x plus 8x. That'll give me plus 16x minus 32. All right, thumbs up. Are we all okay with this? Everyone with me here? Excellent. I feel like you guys are doing great. You guys know how to do this stuff. It's not even that difficult at all. Okay, we're going to skip number 6 and number 7 and number 8 because I want us to get into how we do shortcuts. All right, we're going to learn shortcuts. All right. We'll come back to that other stuff in a bit. We're going to learn some shortcuts. Right. Okay, first shortcut we're going to learn today is if I have any number squared, x plus 1 all squared. I already know that I'm going to rewrite this out twice. Yes, I'm just going to go x plus 1, x plus 1. Yes. And then what I do know is what's going to happen is this first term is going to give me an x squared. That last term is also going to give me 1 squared, which is just 1. And then in the middle, I'm going to get x times 1, which is x, and 1 times x, which is x. So in the middle, I'm going to get 2 times the same thing. 2 times the same thing. So if we want to learn how to do the shortcut, we can do this instead. We can take the first number and we're going to square it. So we're going to put x squared. And then we're going to take the last number and we're going to square it. And we're going to get plus 1 squared is just going to give me 1. Then I'm going to do this. I'm going to go x times 1, which will give me 1x or just x times 2. So in the middle, I'm going to end up with plus 2x. Okay. I hope that's not too confusing. I want us to do another one. All right. If I put in brackets x plus 3 all squared, here's what I'm going to do. I'm going to square my first number. So I'm going to get x squared. At the end, I'm going to square my last number. So I'm going to get plus 9. And then I'm going to go x times 3, which will give me 3x, times 2, which will give me plus 6x. And we're going to get 6x in the middle. Ah, Desmarie, I'm glad. Yes, your teacher and I, same WhatsApp group. You know what I mean? Same. Great minds think alike. Okay, let's try a different one. All right, I want you guys, try your best to use the new rule that we've got and not take the long way around, because unfortunately in grade 10, guys, they're not going to give you a mark for that extra step in the middle because we're grown now. This is big school, no more steps for the small things. We're only going to give you a mark for the shortcut or the answer, pretty much. Okay, if I say I've got x plus 5 all squared, I'm going to give you guys 30 seconds to write it out the way that I have, and then I'll show you what the answer needs to look like. All right. Shortcuts, the first one is for double brackets. This is the first shortcut we're learning, double brackets. All right. Okay, let's check if your answer is going to look like mine. All right. So I'm going to take the first number, square it, and then I'm going to take the last number and square it. So at the beginning, I should get x squared. And at the end, I should get 5 squared, which is going to give me plus 25. And then for the middle term, I'm going to take x times 5, which is 5x, times 2, which is plus 10x. All right, give me a thumbs up. Did you get the same answer? Does yours look like mine? Yeah, Desmarie, well done. Excellent, Tero. Well done. All right, let's do a bit of a different one because I feel like I'm only using pluses and I don't want us to just use pluses. Okay, let's go x minus 4 all squared. Okay, now be very careful with this one because that negative actually belongs to 4. So that's actually negative 4 all squared. So be very careful. All right, 30 seconds, guys. All right, okay, let's look if our answers look the same. Okay, I'm going to take x over here and I'm going to square it. So x squared. And then I'm going to take negative 4 and square it. And I know that negative 4 all squared should give me positive 16 and not negative 15 and negative 16. So plus 16 at the end. And then if we look at the middle, x times negative 4 will give us negative 4x times 2 is going to give us negative 8x, negative 8x. All right. I hope we're all doing okay. Are we doing good? I think this is a nice one. I want to give you a bit more of a challenge because this is grade 10. Let's do this one. 2x minus 6 all squared. Remember to square every number, guys. Remember to square every single number we see. All right, let's have a look at the answers. Are we all ready? Maybe 10 more seconds. I feel like Desmarie's still writing. I'm going to put the pressure on. Do-do, do-do, do-do. Okay, we're done. All right. Okay, let's start with the first one. So we're going to square 2x. And if I square 2x, that's going to give me 2 squared as well. So at the beginning, I should get 4x squared. And at the end, negative 6 all squared should give me positive 36. So 4x squared at the end, positive 36. And then we're going to do the thing in the middle. 2x times negative 6 will give me negative 12x times 2 should give me negative 24x. All right. Give me a thumbs up. How are we feeling about this method? Are we okay with it? Beautiful, beautiful, guys. Amazing stuff. Excellent. All right. So this is the first shortcut we're going to learn. We're going to learn one more shortcut today. Okay, one more shortcut. We are going to learn the shortcut for dots, or difference, the difference of two squares. Okay. Okay. I'm going to show you guys what it actually looks like. And I want to see if one of you guys can pick up on the pattern, because really simplifying and factorizing, which we will do in a little bit, is all about pattern recognition. Okay, that's what we want to do. So I'm going to give you guys an example. I'm going to give you example 1. I'm going to say x plus 2 and x minus 2. Okay, now if we FOIL this, let's do FOIL quickly. I'm going to get x times x, that's x squared. X times negative 2 will give me negative 2x. X times positive 2 will give me positive 2x. And then 2 times negative 2 will give us negative 4. Right. That tells me that negative 2x and positive 2x will cancel. That will give me 0. They don't exactly cancel. They just give us 0. So I've got x squared minus 4 left. Right. Let's do another one. Let's do x minus 5 and x plus 5. Okay, do FOIL. Do first, outer, inner, last. I'm going to do it quite quickly. All right, I'm going to get x squared plus 5x minus 5x minus 25. And then I'm going to notice that 5x minus 5x is 0. And my final answer is x squared minus 25. I'm going to do one more. Let's do one more. Number 3. I'm going to do this. X minus 3 and x plus 3. I think everybody, can you guys see where I'm going? You guys see where I'm going? If I FOIL, what's going to happen? I'm going to get x squared plus 3x minus 3x. Negative 3 times positive 3 will give us minus 9. Those two will cancel. So I'm going to get x squared minus 9. Has anybody seen the pattern? Anybody? What do we think? Good. Two same coefficients. Good. Okay. Like I just need to make it a little bit more, mathy. Tandulwe 2. Make it more Einstein-y for me. Tell me exactly what it is that we're seeing. Okay. I'll give you a hint. We always see the same thing and the same thing. Where else do we see the same thing? Two same coefficients, so he's correct. The coefficients of x are both the same. What else is also the same? What else do we see that's also the same? You see that number? Yes, the constants at the end. That's it, Tandalwe 2. But there is one distinct difference. There is one difference. What is that difference? What do we see? What's the difference between the two brackets? We're correct. The first one, the first term, correct. Yes, yes, Tandalwe, correct. The x's, the variables are the same, the numbers are the same, but the signs are difference and a different. And that's why we call this a shortcut for the difference of two squares. So if we have the exact same thing, except the signs are different, then all we know we have to do is we need to square the first number, square the constant, and then just the two numbers in the middle will cancel each other out. So if we think about number 4, let's go x squared. Oh, not x squared. How, teacher Coco? Ooh, x minus 7 and x plus 7. We don't really need to worry ourselves with what's going to happen in the middle. I already know that my first number is going to be x times x, x squared. My last number is going to be negative 7 times positive 7, which is negative 49. And then I don't even have to worry myself with what happens in the middle, because I know that positive 7x and negative 7x will cancel each other out. Okay. Give me a thumbs up. Are we all okay with these two shortcuts? Especially this one. This one is great. I like this one. It makes life so much easier. Beautiful. Okay, I'm going to give you one more challenging one because we are going to run out of time. Okay, I'm going to do 3x minus 2y and 3x plus 2y. Okay, if you're still feeling like, I'm not too confident about the shortcut, that's fine. You can do the long way. You can do FOIL, but just remember, they're not going to give you a mark for the FOIL part, especially when we have a pattern. Okay, especially when we have a shortcut. They won't give you a mark for that extra step. But if the extra step is how you need to ensure that you get all your marks, by all means, grade 10s, go for it. Okay. All right, I think that's time. Okay, so if I take the shortcut, I know I'm going to take the first number and I'm going to square it. Now, 3x all squared is going to give me 9x squared. And then I'm going to take the last number and I'm also going to square that. And 2y all squared is going to give me 4y squared. And then I know that the last term is going to be negative 2y multiplied by positive 2y. So I need to get a minus in the middle. Give me a thumbs up, thumbs down. How did we do with that last one? All good. Beautiful stuff. Well done, Cyril. Well done, Desmarie. Bukamaso, welcome. I know you came in a bit late, but that's perfectly fine. Remember, we're recording all of these lessons. So if you need to go see them again, they are available for you. Okay. And unfortunately, I feel like you came in just as we were saying our goodbyes because the hour is actually over. And that's where today's lesson is going to end. All right. Next week, we are going to start with factorizing. Okay. And guys, I don't mean to put any riz on my own name, but I am the queen of factorizing. I'm just going to put that out there. Okay, I'm very, very good at it. I'm very good at teaching it. So we're going to have a fun time. You'll see as we go, you're just going to move. It's going to be so nice. We're going to be like, yes, ma'am, I got you. Like I said, guys, not dots. Factorizing is all about pattern recognition. So we're going to be learning how to recognize patterns. And that's why your math teachers are always like, you must learn your patterns, understand patterns. It's because everything else that we do in maths is about recognizing patterns.